welcome to the Autodesk Inventor Automation Academy. In this video, we're going to be expanding on some topics that we focused on in a previous video, where we set up a Inventor add-in. In this video, we are going to be expanding on that by creating basic geometry in Autodesk Inventor. In doing that, we're going to be creating a WinForm and populating it with various buttons and fields and labels, and then showing how you can trigger off those buttons to make basic geometry, in this case, an extrude, based on the inputs given. So without further ado, we'll just jump right in. Okay, so WinForms are one way that you can create a UI with which to interact with Inventor in your Inventor add-in. And we're going to go through kind of how to create that in Visual Studio. You can see one here. They can be very simple, like what we're seeing and what we're going to do today, to very complex with several different tabs and opening, subsequent WinForms with list boxes and all the different types of stuff. We're going to just focus on kind of simple getting it up and started. So I'll go ahead and grab Visual Studio and pull it over, and you can see the example one that I've made before, but I'll walk you through how to make this one from scratch. So if we're going to add a WinForm, what we want to do is right-click on our project, come down here and hit Add, and we have a lot of different options. A lot of these will get us to the same spot, but if we click Form, WinForms, it will actually select it for us, as opposed to having to scroll and find it. But there it is, Form, WinForms, and then we can come down here and come up with a name for our example form. Now, the one previous I've already named example form, so why don't we name this demo form? There we go. And then go ahead and add, and you'll notice that then it will create the new form up here, and we will get a item in our Solution Explorer that we can see here. So if you need to navigate to that, if you lose your tab, you can double click here and it'll bring you there. And we're ready to make a form. So we can come in here and there's a toolbox. Now let's say you don't have that toolbox. You don't know where it is. So I'm going to just exit out of that, and you're looking at it like this. You can go find the toolboxes and different things. You come View and hit Toolbox. You'll notice it also gives you the hotkey Control-Alt-X, and that will come here. You can pin it or make it auto hide, stuff like that. You can actually drag these things around if you like. I don't like. I generally like my toolbox right over there, so I'll just leave it there. Go grab it, see if I can get it where I want it there. Yeah, there we go. So now let's add some labels in. So let's say we wanted to do, some inputs here, where we would get text boxes, and you can drag those in with your labels. And we want to take input of locations, like we're going to place some feature, some sketch or something. So we can come here. Now this is the name of the label. If we scroll down, we can see the text of the label. So let's say we could put in here location X, and we want to, well, let's change the text box before we copy it. So text box, you'll notice here in the properties, you have a whole bunch of things that you can change here. So the name of the box, and we're going to get to this when we create any UI object that we want to interact with the code. You don't want to leave the name generic. So this will say text box. If you have 50 text boxes on your form, it's going to be very difficult to remember that you want text box 23 when you're going to be doing a specific thing. So we want to come in here and rename it. I like to use just leave the name of the item with an underscore and then give a We could say location X or something like that so that we can go find it. You want to try to be consistent with your naming ways of naming these so that when you're writing your code, the autocomplete will kind of help you out there. So we'll put location X there, and then we'll select both these, control paste, get us a couple here, place it there. And then we can come in and edit to our heart's content. So there's location Y, location Z. Now I'm not renaming the labels because I'm not planning on changing anything about the labels programmatically. So I don't need um, to know what I need to call, but I do need to come back and name these other text boxes that we dropped in. So I will underscore loc Y and same thing here. See, there we go. So we have three inputs. Now, one thing that I didn't do, I got distracted by renaming the boxes, is let's say these are going to be numbers, right? So we want them to have their text aligned to the right. So we'll come down here and find the uh, text align. There it is, to the right. And you can shift click like things so that you get them all together. And there you go. You got there. You can also click like this and kind of drag them to different sizes and whatever you're going to need. So we have a location. Now let's say we want to have, let's say we're making some type of hole or shaft creator that we're going to make a circle and then extrude it. So we'll need a radius. So let's copy this one more time, a radius, and then a length that we want to extrude it to. So come grab this one, change this to length. Make sure we change, oh, not our label name. We want our text box name. And our radius. Oh.
Quick break for a second. If this is helping you, go ahead and like and subscribe. That's what justifies us continuing to put time into building these out. All right, back to it.
Here, change the name. Yes. And length. Okay. Now, one thing that these don't have is default values. Now, when you're making these, because you're going to want to probably put in some error handling, one quick way of avoiding things is to make sure everything starts with a good default value. So if you hit go, that you're not getting, your add-in failing. So for these, most of those default values, 0 would be fine. 0 radius and length don't make much sense and would fail. So let's go down to the text value, put in 0 for these three. And for radius and length, I'm just going to put in a non-zero number. So we'll say 5. Now, for our final thing, we need a button to make it go, right? So we'll drop in a button here from the toolbox, adjust these things so it kind of looks good. And you can see that it's looking a lot like the example one we had before. Buttons, we can change the text on them. So we can say create extrude. Up here, rename the button. And there we go. I'm going to drag this down because it's a little high. And if these things bother you in the WinForm, you can actually click on the entire WinForm and you can do properties for it. So let's see if we can take off that text. And you'll notice that currently I have alphabetical selected. You can switch to a categorized where it comes in, what Visual Studio has decided the categories are. These categories don't always make sense to me, so a lot of times I'll just keep it on alphabetical. We're gonna say text. We don't want any text, so I'm gonna delete that. And then there's the image. I always forget where the image is. See if I can find it quickly. We might just move on here. But there is, I think it's under show image. So I'm looking for an S. There we go. Show icon. Hit false. Now we have a nice blank one. Now you can put your own name in if you want it to say something, put your own image in. Here, we're just going to leave it blank. Okay, so now we have a WinForm created. Let's go ahead and save that. How do we get to the code to actually do anything about that? Well, if I double click on the WinForm, it will open up a handler for the load of the form. So if we want to do anything when your form first comes up, then you can do that. If I want to only do stuff when the button clicks, then I can create a handler there. I'm going to do both just so you can see. So I'll double click here and we'll get our demo form load. It handles my base load here. And this, I can, if I wanted to, put in a message box or something that says form has loaded. And this would fire anytime the form is loaded. Now, is that useful? Probably not. But I could also come here and say text box and set the radius. So let's do the length equal to, oh, not the actual text box. I want the text box dot value. Is it not text back? Oh, dot text. That's what it is. Yeah. Equals, and we're going to set it equal to 10. Now the text box dot text is a string. Visual Studio, you'll notice that we get these green squiggly marks. That means that it's like, something's kind of weird here. We're okay with it, but it's a little weird. That's because we're taking a double value and converting it to a string. So if we wanted those to go away, I gotta, we can do that. It looks like we have another error here as well that we're not going to worry too much about, but that you can kind of see a warning of what it might look like if you're doing conversion, implicit conversion. Now, once again, those warnings, we're okay with them. They're a hint of like, oh, something might be wrong here. So let's say, how would we use this? Let's say we had a whole bunch of options and parameters on our part, and we wanted to load default values based on those or whatnot. We can do math here as the form loads, and then populate default values in text boxes or even combo boxes. I see it often. Combo boxes you need to preload for when the form loads, so it's not just on blank. So you'll see sometimes you'll get a combo box, selected index equals 0. Just select the first one. I'll go ahead and take this one out. We don't need that. So there's the load handler. Let's go back to the designer on our demo form, and now I'll click on the button. I'm gonna make this button a little bigger. Okay, so if I double click here, you'll see just below our load handler, we get a button underscore create extrude dot click event. And here we can do things with that. So let's say we want to get all the values into variables so that we can use them in making our extrude. So I'm going to here and we're now doing VB coding here. So we'll dim up a variable and we'll call this first variable X location, right? As a double. Double is a number. And then we want that to equal text box underscore location X. There we go, dot text. And then we can do that 3 times. YZ. Change this to YZ. And you can see in Visual Studio that I get kind of autocomplete options that I can tab through to get to. So there's our three locations. Let's go get the radius and the length. The dim radius as double equals text box. And then we can just down, down, down. There's radius tab dot text. And then I'll just copy paste that one for length is the last one, right? So change this to length. And here we have code where we will load in those values to variables. Now, once again, this has no error handling. So if somebody put Bob in here, the word Bob, and we tried to shove it into a double variable, Visual Studio is going to yell at us and we're going to get a failure, right? So adding in some error handling to say, hey, that's not a valid input, and bouncing out, you can do that. I guess I'll show you real quick what that might look like. So if I came in here and said, okay, try catch. Try catch statement is a simple try to do some line of code. If it fails for whatever reason, uh, switch over to the catch area and do that. And so it can help you fail elegantly or gracefully as opposed to throwing up, crashes in your user's face. So, but one thing when we talk about doing try catches, or if statements or for loops or any of the things that we'll eventually get into, we're going to start talking about a concept called scope. Now, scope in your code is when variables kind of exist. So if I were to take our X location variable and place it inside the try catch, and then afterwards, I tried to reference that. So I said, hey, I want to say X location, um, you know, plus, actually, why don't we do this? This won't make a whole lot of sense, but we're just going to do it anyway. So Z location equals X location uh, plus Y location, right? Okay, it's going to yell at us for two different types of reasons. Well, one reason is they're all not in scope, but they're not in scope for two different reasons. So first off, we'll start with the obvious. Z location and Y location are being used before they've been declared. So code reads from top to bottom. So this is not going to work. If we switch these up here, you'll notice boink, those red lines go away. Okay. And you can tell when it's not in scope because you'll get warnings or errors like this. Is not declared may be inaccessible due to its protection level. So this is above. Why isn't it seeing it? Well, it's inside a nested, area of the code. You got this try, catch. It would be the same if we stuck it in an if loop or a for loop. So how do we solve this? Because we want, to uh, put this in the try catch, but we also want access to it. Well, we have to declare it above. So we'll go ahead and dim X location as double, and then we can just leave it like that, or we can set it equal to nothing or some default value that way. And then we take off the declaration here and we just say, hey, X location, we're going to try doing this. And if it fails, then we can do a couple things. One, we have a default value. We would just keep with the default value and do nothing. But likely is the user put in some bad information and we want to tell them that. So we'll go message box and say X location value is invalid. Please enter valid input. Nice. And we use the word please, right? So, okay, we get the message box. Now what do we do? Because we don't want to continue. If this kept going, it would continue and we'd be using the default value, which is 0, but they don't know that because it's just in the code. Even if they put like let's say they put 54T and they, accidentally fat fingered the T in there. So what we want to do is then exit out of the sub, and we'll just call exit sub. And we could do that with all of the different inputs. And we'll leave it like that so we can kind of see the difference. So there's a little bit of error handling for you, very basic error handling. Also talked a little bit about scope of variables. We'll get more into that as we keep going. But we're grabbing values off of our form, our WinForm. So now, how do we actually get our application to launch our WinForm? If we come up here to our standard add-in server, if you remember this one from a previous video when we actually set up the add-in, we're going to go to where we had the code that launched the message box. Now, I've already changed that code, but we'll go look at it. So let's see, user interface. We come down here. We had this, let's this one. Yeah, sample button. Here we are. So we have our sample button on execute here. And we had our example form that we're launching. So previously we had this message box that said button was clicked. What we're going to do now is create a instance of the form that we just made and then show it to the user. Okay, so this is the one that I showed you at the beginning. I'll go ahead and comment this out there, and then I'm just actually going to paste it and rename it. So here we just need this name is a name of variable. We don't really care what it's named, but it probably should be something that makes sense. So I'm just going to say demo form 1, kind of match what I did there. But this, we need to match exactly what we named the form. So we'll say demo form. I'm going to put a carriage return so you can see that a little better. Then we need to grab that variable we just made and call show. Now, this is one way of launching a Windows form. There are a couple other different things that you can do to, for example, launch modal. I'll kind of show that just really briefly, but you do have show dialog that will launch a modal. If you don't know what that means, the difference is kind of how much you lock down the rest of the screen. So whether you can interact with Inventor or not. Currently, we're just going to keep it at show though. So this will launch our form now. So if we come here and we're going to save it and launch Inventor, we'll see what that looks like. I'll let Inventor launch off screen as always. Drag it over. Come on, Inventor. Here we go. So we've got Inventor. We have our current add-in is on the tools of the part. So we need to open a part, whether new or otherwise. Then we're going to go to tools. And here's our button that we made in a previous video. And now we've switched it so it's launching our new menu we just made, our new UI. So you can see that even though we put in 2 5s, we're hitting that load code. That gives us the 10. And if I hit this, well, nothing's going to happen because it's just doing numbers behind. But let's put in some bad value. So I'm going to put that name Bob into X, and we should get, hey, X location value is invalid. Please enter valid input, just like we did. Now, if we do that, let's go ahead and put this back to something valid and do it in something that we didn't error handle. Let's see what happens. Boom. We just crashed Inventor because we're hitting this and it's saying, hey, that doesn't work. And if we continue, Yeah, it's going to get mad at us, and away goes Inventor. Uh, so error handling is important. Um, okay, so that's the basics on creating a WinForm. There's a lot more we could go into, um, especially like if we look at the toolbox, at all the different tools that we have. Um, we here at KETIV, when we're, on the automation team, we use a lot of these like list boxes or data grid or combo boxes is probably something that I didn't show you that you'll use a whole lot as you're getting started. So we can pull a combo box over here and kind of show what that looks like. Um, and you can come in here and put a collection of different values. So I'm just going to put numbers. Oop. And then when you actually run it, you can click down and see those values. Um, there's a lot of different things you can do with WinForms, but we'll kind of stop there for now, and we'll probably get into some of that stuff in future videos. So let's head back to the PowerPoint. Hey, let's pause for a minute. Who are you working with for your Autodesk tools today? If you're already learning from us, it might be worth a conversation. At KETIV, we back it up with strong support, a smart, easier renewal process, and deeper expertise across the automation, data, and simulation. If you're open to it, we'd love to work with you. Okay, let's get back to learning. Okay, so we've made our WinForm. Now we want it to interact. So this is some of the stuff we kind of went through and talked about, right? We added our WinForm. We went and found it. There's kind of an example of it. We showed our changing of the name and getting the different variables all set up. Now we want to go make extrudes. Now, these are a little more complicated than the extrudes that we're going to do today, but you could do these extrudes. And we're going to kind of show how those things, how you make the calls in the API code to make an extrude. So let's go ahead and look at that. We have our documentation that if you're wondering where we get these lines of code from, you can look up the Inventor API documentation and look up, for example, here I'm looking up extrude definition, and we can look at that as well. So let's do, and here's the code we're going to look at, which is very simple, straightforward. We're just going to take those values in and make a circle on a sketch and then extrude that circle. So let's jump right in. We'll bring back Visual Studio. We'll keep with this lovely UI we've created here. And so how do we get started? Well, first we're going to have to set up a couple different things. In the Inventor API, we have a couple objects that allow us access to things. So I'm going to make a variable here, OTG, as transient geometry. And we're going to set that equal to an Inventor application transient geometry. Now, what is this? This is a collection of, let's see if we can get this thing to, oh, we also have to import Inventor at the top. So that's an important thing of your, as you get started with a new file here. We can put imports Inventor up here. If you didn't want to do this, if you were just calling an Inventor thing once, you could come down here and say Inventor dot transient geometry. But if you're using Inventor calls a whole lot, that's going to get tedious. So we'll just at the top say imports Inventor there, and then it'll recognize all those. Okay, so what is transient geometry? It's a collection of different commands that we can use. There's other things like transient objects that you can get object collections from, different things. So you'll see this crop up in the series often. But currently, we're going to use it to get access to create point 2D because we're going to need to make a point 2D on our sketch to place a circle on. So that's what we're going to do. You'll notice also that I'm calling this G Inventor application. You might be, what is that? Where is that coming from? Well, believe it or not, that is coming from our standard add-in server. So if we come here to standard add-in server, there's actually a public module globals down at the bottom. And here we can set up some global variables. And the main one that already exists there, or the only one, is the Inventor application. And that's already set up in the template. You don't have to worry about it. So whenever you want to grab the Inventor application, you can do it like this. And if you want to make other global variables there, you can do it by, just making another variable. I guess I can show you. Just public G underscore is only just a naming convention, but it is helpful. And I'm just going to call this other global variable. We can set it equal to a double. So let's say we had some value that, not equals as. And we can set it right here if we wanted to, like if we had some number that we needed to keep track of, or in your code, if you needed to set things, this is how you'd make a global. And if we come back to our form, here now we can access our global variable, just like that. Okay, so we have our transient object. What else do we need? Well, we need the part document, right, that we have open. So let's dim a document up here as a part document. And we're going to set it equal to, once again, the Inventor application. We're going to grab the active document. Okay, there's our active document. And we need the component definition of that part document. Now, we're not going to go into the differences of component definition part document right now, but that is something that is important we might touch on later. So let's go in and get a component definition as part. You can have part component definitions. You can have assembly component definitions. Let's go. Now we're going to grab our part document and say component definition off of that. And this component definition is what's going to hold your sketches, your features, all the different stuff of what you think of in a part in there. So we got our component definition. Now, why did we do all this? Well, we want to get access to the sketches because we're going to add a sketch because that's kind of the first step, right, of making an extrude. We need a sketch. So I'm going to dim up a sketch as a planar sketch. And we need to go grab the assortment of sketches inside the component definition. So we'll grab the component definition, sketches, and we're going to add to that. So we hit add, and then we need to get a work plane that we're going to define the sketch by. So there's a lot of different ways you can make a work plane and then reference it by name. I'm just going to grab one of the ones that are always there, so one of the origins, and I'll do that by grabbing the comp definition and get the work planes object, and I want the second item. I believe this is, I always forget which one it is, like the YZ plane. But they're always in the same order, 1, 2, and 3. Remember, Inventor objects are one-based lists, so that means they start with 1, 2, 3, as opposed to almost everything else starts with 0, 1, 2, 3. So that's something that can get you if you're used to normal numbering schemes. Okay, so we get the sketch. Next, we're going to need to define a center point for our circle on that sketch. So let's go ahead and do that. So dim, we'll call it, I don't know, center point as point 2D. We're going to set that equal to, now here's where we use that transient geometry object that we made. So if I come here, just OTG, tab, grab that one, and we want to create point 2D. And this will allow us to make it's not making a sketch point. So that's one thing that's important to notice here. You're not going to actually see this point as a sketch point in the sketch. You can do that. You can make a point 2D and then make it a sketch point, but currently we don't care about making it a sketch point. But now we can input the user's input into this to define where that is. So I mean, if we do 0, 0 here, it's going to always be 0, 0. But what we really want is our X location and Y location. Now we did put Z location in here, which probably doesn't make any sense. Oh, I need to delete this line. That would make no sense. So I guess we could have the Z change, make a plane that changes where it's putting on. Right now, we'll just ignore the Z input. Okay, so we got our center point. Now we're going to make a circle. So we'll just name it, I don't know, circle 1, just in case later we want to make other circles. As sketch circle equals, now we need to get that sketch object and get the sketch circles dot um, add by center radius. That's the one we want. We can do by 3 points, but we have everything set up to do by center radius. So the first one, if we just hover over this, it's going to give us kind of what we're looking for. It's looking for a center point. We made that, but previously as a point 2D, and a radius. So we'll grab our center point, plop that in, and then we need to go grab our radius. Now, one thing to note is that the Inventor API is in centimeters. So if we were thinking that we were going to be in inches, then we would need to adjust this. So we'll go in and hit 2.54 and just add those in there. We have that adjustment. Okay, so now we have a sketch circle. If we ran this, we'd get a circle. Maybe we should run it and just kind of show that. I'll go ahead and launch Inventor, and we'll make sure that it's working. We haven't written some bad code here. So we'll launch off screen as always. Drag it over here. Oop, not open. Cancel. It moved on me. Here we go. New part. And tools is where we'll launch it. Okay, 0, 0, 0. We'll just leave it here. The length doesn't mean anything yet. We'll hit create and rotate it. We've got ourselves a circle that should be, if we go into our measure tool, 10 in diameter. Is that correct? No, it doesn't look like correct. Are we passing in the length? I'll have to go check that. Why? Oh, because we passed in a radius. That's why. So that makes sense. It actually is correct. So there we go. You can see it's working there. Let's go ahead and get out of that. Drag this back over. We'll actually crash that, or not crash, force quit. And now we're ready to do the extrude part. Well, what does an extrude look like? We've just made a sketch circle. Let's make an extrude. So first, before we do anything, we need to get a profile to make an extrude. And then we're going to make an extrude definition. And then we're going to make a extrude from that extrude definition. It's a little bit weird that you have that definition and the extrude object, but that's just how the Inventor API works. So we'll go ahead and go dim. We're going to make a profile object as a profile. Now you can make profiles from complicated sketches, meaning that a sketch that has multiple profiles. In automation, I'd highly suggest not doing that. It's just a whole lot easier to make sure that you have one profile to one sketch. Make sure it works every time. So we're going to say, oh, sketch dot profiles. Oh, I forgot an equal sign. Profiles, and then add for solid. And that'll get us our profile from that sketch that we made. And next, we're going to make the extrude definition. As extrude definition, which equals, we're going to grab the component definition and grab, that's right, features and extrude features. Not extend, extrude, there we go. And then we want to create an extrude definition. So here we can see it's asking for a profile and then an operation. So the profile we're all ready for. That's our profile object we made. And then this is an enum. And if you can see down here, Visual Studio is really nice. It's telling us kind of what it's looking for here. So we have these part feature operation enum dot cut intersect. We want a join on this one. New body would probably work as well. And that is making an extrude definition. Now, with the definition, that doesn't do anything for us. We need to make the actual extrude object. But before that, we're going to set the extent, so how far this is going to go. So extrude definition dot set distant extents. And here we're going to pass in that length value, and of course, times 2.54, because we want inches. And it's yelling at us. So, oh, it wants that enum. So let's go ahead and give it because we got to tell it, are we going positive, are we going negative, or are we going both? So we'll go, just type in K because it'll give us a guess of what we want here. So K negative, K positive. We'll keep positive now, but we can maybe play around with going both. And then once we have the distance taken care of, we're going to, now I'm not going to use this variable, but just so we have it as extrude feature equals, and then this is the part of the call that matters. We're going to go grab the comp def and features and extrude features. We're going to say add. And then we're going to add the extrude def. Looks like it's having a little bit of a problem. Let me double check here. Comp def features. Oh, that's why. It got me again. Extend features. Extrude features. There we go. And then add. And there we have our code that will get us an extrude. Now, you can do the same type of thing if you want to do a revolve, or if you want to, if you wanted to make this a cut, you'd change this from a join to a cut, and you can kind of get those complex shapes that you're after, doing piece by piece. But for now, let's go see how it looks. We'll run Inventor and make ourselves an extrude. Pull this over here. New part. Go grab tools. Launch our command. So we're going to put this at a slightly different, let's see, we have a radius of 5. Well, we'll do the first one, and then we'll change some stuff. Okay, so there's our extrude. Woohoo, we got an extrude. Then we can come in here and change the X location to, I don't know, 30. And then change this to 2, this to 15. Do it again. There we go. So that is how you make an extrude in an add-in in Inventor API. And you can kind of grow on this with all the different basic geometry to be able to make a part configurator that can automatically make you parts. And you can just kind of imagine all the different applications that you can do with that. Thank you.
Let me pause for a moment before we continue. If you're enjoying this course, what you're seeing here is really the starting point. We've worked with teams like Oldcastle Infrastructure to turn concepts like this into real measurable outcomes, including an 80% reduction in layout time. If you want to fast track introducing automation to your organization, reach out to us and get started at KETIV.com/automation.